All right, let's take some time and look at one more problem. Okay, we have here the antiderivative of u minus 2 all over the square root of u du being evaluated from 1 to 4 and being evaluated on the closed interval from 1 to 4. So let's rewrite this here. Into two separate fractions. So u, and remember the square root of u is the same thing as u to the 1/2 power, minus 2 over u to the 1/2 power du. And we can simplify that a little bit, clean it up a little bit before we find our antiderivative. So u to the first over u to the 1/2, subtract the exponents. That gives us u to the 1/2 power. And then bring this u to the 1/2 power up. So 2u to the 1/2 du. Okay, so now we'll find the antiderivative of u to the 1/2 and find the antiderivative of negative 2 times u to the negative 1/2. Okay, u to the 1/2, if we add 1, that's the same thing as adding 2 over 2, so that gives us 3 over 2 as our exponent. And if we divide by 3 over 2, that's the same thing as multiplying by the reciprocal of 2/3. And then here, if we add 1 to the exponent, that will give us u to the 1/2. And if we divide by 1/2, again, that's the same thing as multiplying by 2, and 2 times 2 is 4. Evaluating from 1 to 4. So we have 2/3 times the square root of 4 raised to the 3rd power minus 4 times the square root of 4 minus, evaluated this at 1, 2/3 times the square root of 1 raised to the 3rd power minus 4 times the square root of 1. So I just change the fraction notation back into roots and exponents. All right, so the square root of 4 is 2. 2 times 2 to the 3rd power is 8. So it gives us 16/3 here. The square root of 4 is 2. 4 times 2 is 8. Minus, the square root of 1 is 1, so minus 2/3. And then distribute this minus here, so that becomes plus. Square root of 1 is 1, so plus 4. So we have 16/3 minus 24/3 minus 2/3 plus 12/3. And that all 16 minus 24 is negative 8. Negative 8 minus 2 is negative 10. Negative 10 plus 12 simplifies to be 2/3. So the antiderivative of u minus 2 all over the square root of u du evaluated from 1 to 4 is 2/3. Okay, that takes care of the fundamental theorem of calculus. Thank you.